Several of you, most of you, have a curve in your 3D project, and I promised you that I was going to explain to everyone how you're going to calculate that part of the circle, especially if it's something that you need to not calculate twice. So let's talk about some definitions first. Here I have my circle, center here. A sector of a circle is this pie-shaped wedge. So if I were to shade all of this, I'm shading a sector of the circle. Now this particular sector of my circle has a 55-degree angle here out of 360 degrees total of the circle. Well, I know that the area formula for a circle is pi r squared. That would be the entire circle. If I just want the area of this sector, then I just actually want this piece that would be 55 out of 360 degrees of the total area of the circle. So that's how I would find the area of the sector. Well, what about a segment? A segment of a circle is just this curved piece. It's not a full half circle. It's when I take what we call a chord, a straight line that goes from one edge to the other of the circle. Both ends are on the circumference instead of one edge being at the center of the circle. This is a segment. Now, when I look at this segment of the circle, I can see that it is actually related to a sector, so that I could go ahead and I could bring the radius out to see what the sector of the circle would be. And now you can see that this segment is the curved part of the sector, and then I've got this triangle left over. So let's go back to our 55-degree central angle here. If I were to count this as the segment that I'm interested in, if I'm interested in this segment right here, well, then what I would need to do would be to start with the area of the sector, and once I know the area of the sector, I would subtract the area of that triangle. So this triangle here, if I take this area out of the area of the sector, so the area of the sector minus the area of the triangle gives the area of the segment. I start with the area of the whole thing, I figure out the area of this triangle, and I subtract it, and what's left is the area of this little segment. Now, how does this apply to your projects? Several of you have a half circle as part of your project. So let's start with a circle, and let's say, okay, well, we've got this half circle here. Right here's my half circle, but let's say that this half circle actually connects to, let's say, a rectangle. And so we've got this rectangle here. I don't know what this project might be, but I've got this rectangle that connects to my half circle. Well, when I am doing calculations, I can't calculate the area of the half circle and the area of this rectangle without figuring out what this segment is, because I can't count that twice. I've got to take it out once. So the area of my rectangle and the area of my half circle minus this overlap, I have to exclude that. Well, to figure out the area of this segment that I need to take out, I'm going to want to create a sector again. A sector of a circle, remember, is the pie-shaped area. I'll need to know this angle to figure out the area of the sector. And then I take out the area of the triangle, and what I'm left with is this little piece, this area of the segment. So let's say that my radius is 3 centimeters. Now I haven't measured this, so this is a total guess. And let's just say that this is 60 degrees. So the area of the circle would be pi r square, which is going to be 3 square would be 9 pi. That would be the area of the entire circle. But all I want is this 60-degree sector to start with. So 60 degrees out of 360, that's the same thing as 1/6 of the area of the circle. So that's my area of the sector.